बिस्मिल्लाहिर्रहमानिर्रहीम। वेलकम टू द चैनल। माय नेम इज़ आसिम अमजद। इस वीडियो लेक्चर के अंदर हम बीम डिफ्लेक्शन यूजिंग सुपरपोजिशन मेथड के थ्रू सॉल्व करेंगे। हमने प्रीवियस वीडियो लेक्चर्स के अंदर डबल इंटीग्रेशन मेथड और सिंगुलैरिटी फंक्शन और मैकॉले मेथड की मदद से डिफ्लेक्शन ऑफ अ बीम जो है वो फाइंड की थी। बट for the common beam configuration, when the beam bending remain in the linear elastic region, we can employ the superposition technique to determine the beam deflection from the tables. And as a recall, we did an example already of some common results that can be found in the beam deflection tables. So, using the superposition method, we can find the resultant effect of several loads that is acting on a member at the same time by adding the contributions from each of the load applied individually. So there must be a linear relationship between the applied load, the stress and the resulting deflections. So हमने previous video lectures के अंदर maximum deflection for simply spotted beam when a point load is acting at its center वो कैलकुलेट की थी, जिसके यहाँ से इस पॉइंट तक डिस्टेंस L/2 है। और we know that from our previous video lecture that is the deflection of simply spotted beam, the maximum deflection for simply spotted beam is PL³/48 EI, and that is occurred at the center of the beam. Then we derive the relationship for simply spotted beam with the moment applied at the right end, and we come up with this result that the maximum deflection is minus moment applied at the end over 9 times L square over square root of 3 times EI, and that would be occurred at a distance of x is equal to L over square root of 3, or you can say 0.577 times L. Moreover, you can also found some other examples from the beam deflection tables, और beam deflection tables आपको इंटरनेट से भी easily available मिल जाएंगे, और different mechanics of materials की बुक्स के अंदर भी आपको मिल जाएंगे. So simply spotted beam for acting the uniformly distributed load that is shown here W and the length of the beam is L, we can find from the table that the maximum deflection would be occurred at the center of the beam, and the value of deflection is 5WL4 over 384 times EI. We can also derive some relationship related to the cantilever beam in our previous video lectures, and you can recall that when the point load is acting at the end of the cantilever beam and the length of the beam is L, the maximum slope and deflection would occur at the end of the beam, and the maximum deflection for the point load that is acting on a cantilever beam is PL³ over 3EI, and the value for deflection, or you can say theta, or the slope is equal to PL square over 2EI. So we actually did this thing in our previous video lectures. We also did this and these things in our previous video lecture, and you can also go through that videos, and we can come up with these values that the maximum deflection would be occur at the end of the cantilever beam while applying the uniformly distributed load or uniformly varying load, or you can say the ramp load. The maximum deflection and the maximum slope would be occur at the end of the cantilever beam. So you can also go through these stuff into the previous video lectures, or you can also find these values from the beam deflection tables. Okay, so now here's our worksheet number 1, and in our worksheet number 1 we have to find the beam deflection at mid-span for the steel beam loaded as shown below, and the modulus of elasticity for the steel is 29 times 10 raised to power 6 psi, and the area of moment of inertia for the cross section is 13,020 inch power 4. So here is the representation of the beam, the uniformly distributed load that is acting on there is 250 pounds per foot, and the point load that is acting out there is 2000 pounds, and the length of the beam is 60 feet plus 60 feet is equal to 120 feet. So we simply use these relationship, this value for the simplest supported beam. When the distributed load is acting over there, the value of deflection is 5 WL4 over 384 times EI, that is shown here. And for the point load, you can use this relationship, that is PL cube over 48 EI. And as we taken the upward direction positive, so here we put a negative sign that indicates the direction of the load. And now simply substitute all the values in this term, and we also know that the maximum load is uttered. We also know that the maximum deflection is occurred at the center of the beam, that is L by 2. So simply substitute all these values, and then here are some conversion factors, and the answer for deflection is minus 3.09 inch, minus 0.33 inch. So all the stuff is now in inch format, and then simply do the subtraction, and the answer is 3.42 inch down. That indicates the direction of the slope. It's acting on the downward direction. ओके, अब हम वर्कशीट नंबर 2 को सॉल्व करेंगे, और वर्कशीट नंबर 2 के अंदर जो केस प्रॉब्लम हमें गिवन है उसके अंदर हमें बीम डिफ्लेक्शन को फाइंड करना है एट द एंड ऑफ द कैंटिलीवर बीम, and the loading is shown below. The modulus of elasticity is 200 gigapascal, and the area moment of inertia is 6 times 10 raised to power 9 millimeter 4. So we know that from our previous video lectures that the maximum deflection and the slope is occurred at the end of the cantilever beam, and here is the situation. लेकिन इस प्रॉब्लम के अंदर हमें यहाँ से यहाँ तक का फ्री एंड है जिसके ऊपर ये रैंप लोड जो है वो एक्ट नहीं कर रहा, और हमें जो डिफ्लेक्शन फाइंड करनी है वो इस पॉइंट पे फाइंड करनी है. तो ये जो दो टर्म्स हैं ये हमारी इस पॉइंट तक के लिए वैलिड है. सो फॉर दैट केस हम क्या करेंगे, हम यहाँ पे इसको फाइंड कर लेंगे y2 के टर्म्स में. तो ये लेंथ हमारी L1 है और ये लेंथ हमारी L2 है. ये जो डिफ्लेक्शन है ये y1 है, और ये डेफिनेटली डिफ्लेक्शन जो है वो y2 होगी. तो बाय यूजिंग दिस ट्राइएंगल, तो हम यहाँ पे y2 ओवर L2 करेंगे, तो यहाँ से हमारे पास जो एंगल है थीटा, टेन थीटा, वो आ जाएगा. और वी नो दैट ये जो एंगल है ये बहुत स्मॉल है, सो वी कैन कन्वर्ट इट एज थीटा. देन y2 इज इक्वल टू L2 times theta. So we have to actually find the deflection at the end, and we know that the total length of the beam is 11 meter. So 11 y for the 11 is equal to y1 plus y2, and y1 की वैल्यू हमारी इस टेबल से आ जाएगी, डिफ्लेक्शन के टेबल से, WL4 over 30 EI, और इसकी एरो की डायरेक्शन जो कि डाउनवर्ड है, तो इसलिए नेगेटिव का साइन आएगा. और अगेन यहाँ पे जो आपकी L2 है इसकी वैल्यू हमने यहाँ पे फाइंड की है, दैट इज L2 टाइम थीटा, और थीटा के अंदर हम सब्स्टिट्यूट कर देंगे ये डिफ्लेक्शन, एंड देन सिंपली सब्स्टिट्यूट ऑल दी वैल्यूज इन दिस इक्वेशन, एंड देन अप्लाई सम कन्वर्जन फैक्टर, एंड यू कम अप विद दिस वैल्यू दैट इज 0.836 मिलीमीटर डाउन. इन द डिफ्लेक्शन जो है वो डाउनवर्ड है, तो इसलिए यहाँ पे हमने उसको डाउनवर्ड यहाँ पे लिख दिया है. सो इट्स ऑल अबाउट सुपरपोजिशन मेथड. So we did a double integration method, then we learned about Macaulay method, then we learned singularity function, and now we learn a superposition method. So all these methods are used for finding the deflection of a beam or the slope of the beam. Or next time we will continue our lecture by discussing the indeterminate beam. Thank you.